I'd like to spend this video talking a little bit about the horizontal compression or stretching of graphs. As an example, let's look at the graph of the basic sine function. That's going to have a period of 2 pi. I'm going to cut that up into quarters. It's got an amplitude of 1. So the peak is going to be up at 1, and then it drops down to -1, back up to 0. And that cycle there is just going to repeat in both directions. So what about the graph of the sine of 2 times x, right? Well, if you've seen the videos on graphing the sine function, replacing our x with a 2 times x chops our period into half. Our period is now down to pi, right? And so the quarters, pi over 4, pi over 2, 3 pi over 4. Right? The amplitude is still 1 and -1, right? But now we reach the peak earlier. We reach it at pi over 4, and then down to pi over 2. I'm sorry. We reach our peak earlier at pi over 2, then we go down to 0, then down to -1, back up to pi. So this cycle, since we replaced x with 2 times x, has been compressed horizontally by a factor of 2. Okay. Generally speaking, if we have some function f and replace x with k times x, if the absolute value of k is greater than 1, the graph of f of x is compressed horizontally. If the absolute value of k falls between 1 and 0, then the graph of f of x is stretched horizontally. So this is the general rule for the graph of any function. Right? And we saw the application of this one in that sine graph example that we just looked at. So now I want to think about this in a very intuitive manner. So suppose f is just a DVD player. Right? So on my axes here, I'm going to have time, right? And as time progresses, my function is just going to show me the movie, right, in regular time. So maybe at a half hour, right, there is some sort of murder that's been committed, right? And then maybe at 1 hour, we discover who committed the murder. Right? And then the rest of the movie is spent trying to find the murderer, and let's say it ends at 2 hours with the murderer getting shot. Okay? So here we have a plot of a movie that is shown to us by our DVD player in normal time. So it just progresses, normally. The events show up normally on the television screen. So this, right, is what f of t looks like. Replacing t with 2t, right? Now I'm speeding up the time by a factor of 2. I'm in fast forward, right? Well, if I'm in fast forward, then the murder no longer happens a half hour in. Since I'm going twice as fast, it's going to happen a quarter hour in. Right? So now this murder is occurring much closer to the y-axis than it was at normal speed. Right? And now the murderer is going to be found a half hour in. And the whole movie ends not at 2 hours, but it's now going to end 1 hour in when the murderer is shot, right? So the entire movie still happens, right? It's just that it's all going to happen closer to the y-axis because I'm watching the movie twice as fast. Conversely, let's say I replace my t with 1/4 times t, right? Now I'm slowing time down by a factor of 4, right? So all these events are going to happen farther out into the future, and so I'm going to stretch the unfolding of the plot horizontally, right? So when we think about stretching and compression of any graph, we can think of it in terms of fast forward or slow motion if we think of getting away from the y-axis as progression of time.